Hello again, folks. How are you all doing? So I'm just going to run through the ordinary level maths assignment for complex numbers that I gave you. And if you have any queries regarding any of this, please just let me know. Okay? So we're going to start off with this question here. Now we just pop that like that. And here we go. Okay. So the Z1 is minus 2 plus 3i. Z2 is equal to minus 3 minus 2i. And Z3 is equal to Z1 minus Z2. So plot them on the diagram diagram and label each point clearly. Okay, so we'll do this part here. Or actually, we'll do this on the other board. So, just give me 1 second. And we'll ask the question. Now, sorry, you just move this up here. And then we'll plot this as follows. Okay, so you draw your diagram diagram. That's not the one I wanted, it's this one here. Like this. And so make it nice and spacious so you can see everything. Like so. And then what you're going to do is, so Z1 is minus 2 plus 3i. So you go to minus 2 plus 3, and you write Z1. Z2 is minus 3 minus 2i. So it's going to be there, and you write Z2. Now, it also says that Z3 is Z1 minus Z2. So Z1 minus Z2 is equal to minus 2 plus 3i minus 3 minus 2i. So it's minus 2 plus 3i plus 3i plus 2i. Okay, sorry, that's plus 3. So that's minus 2 plus 3, which is 1 plus 5i. And 1 plus 5i, I'm actually going to have to rearrange this slightly, just to make sure it all fits. So, just plot this again. And again, just to show us how to draw it. So you got 1, 2, 3. This is the real axis, and this is the imaginary axis. Okay, so again we had minus 2 plus 3i, minus 3 minus 2i, and then the last one was 1 plus 5i. And hence you label them Z1, Z2, Z3. So that was that question there. It's fairly straightforward. Okay, we'll move down there. Here. Right. So the next question was, investigate. Now you get one of these every year. So investigate if the modulus of Z3 is equal to the modulus of Z1 plus the modulus of Z2. So that's all there was to that one there. Now, so the modulus, so remember the modulus is you use the square root formula. Okay, and okay, so we're going to get the modulus of Z3. So Z3 is equal to 1 plus 5i. So the modulus of Z3 is equal to the square root of 1 squared plus 5 squared. So that's 1 plus 25, which is the square root of 26. Now, the modulus of Z1 So Z1 is equal to, if we just look back up here, Z1 is equal to minus 2 plus 3i. So you can do so the modulus of Z1 will be the square root of minus 4 squared plus 3 squared, which is equal to the square root of 13. And then if you want to get the modulus of Z2, so we know that Z2 was equal to minus 3 minus 2i. So Z2 is minus 3 minus 2i. So that's equal to the square root of minus 3 squared plus minus 2 squared, which is equal to the square root of 13. And then you can then see, so is the square root of 26 equal to the square root of 13 plus the square root of 13? So it's important for you to remember that it's not. Okay, and you can check that by putting it into your calculator. So you just write, no, it's not. Okay, and the last part of this question then was, write Z4 in the form x plus yi. So what this question really means, or what it's trying to get you to do, is it's trying to get you to write that in a form, in a normal complex number. So Z1 over Z2. And again, if we look at our question, it's minus 2 plus 3i all over minus 3 minus 2i. So whenever you're asked to write one like that, if it's a fraction, you always multiply by the complex conjugate. Multiply above and below the line. And that's going to equal. So minus 2 times minus 3 is 6. Minus 2 times minus 2i is minus 4i. Then you have 3i times minus 3, which is minus 9i. And 3i times 2i is plus 6i squared. And that's going to be written all over 9. Minus 3 times minus 3 is 9. You're going to have plus 6i minus 6i minus 4i squared. So that's equal to 6 minus 6, so it's 0 minus 13i over 13, which is 0 minus I. So again, that's just multiplying the sets. Look, minus 3 times minus 3 is 9. Minus 2i times minus 3 is 6i. Minus 3 times 2i is minus 6i. So 6i minus 6i is 0. And then you have minus 2i times 2i, which is minus 4i squared. But remember, I squared is equal to minus 1. So that becomes plus 4. That's how you do that. So that was that question there. Okay. We're going to look at the next question there. And the next question was this one here. So the complex number is shown in the diagonal diagram, writing the values of A and B. Okay. So we'll just get a picture of this one. Now it's important to know these are going to be worth 30 marks this year. Okay. And then the next part of that was you answer 2 and 3. Okay. So we do A first. So the complex number A plus BI is shown in the diagonal diagram. So you can see here A plus BI is there. So you always go up to the real part first. So it's going to be 3, and then you go across minus 1i. 3 minus 1. And that's all there is to that part there. So it's 3 minus I. Okay? And then for this part here, okay. Now, it says plot Z2 on the diagonal diagram. So if you just plot that on the diagonal diagram, okay, so it says plot minus 1 plus 2i. So minus 1 plus 2i is there, and that will be Z2. Okay, so you now have that Z1 is equal to 3 minus I, and Z2 is equal to minus 1 plus 2i. Okay. Now, So that was that there. Now the next part is write that in the form. So you see this every year. Z3, Z1 over Z2. Write it in that form. So Z3 is going to be equal to 3 minus I over minus 1 plus 2I. You're going to multiply by minus 1 minus 2I. So you always multiply. So you see a pattern here. This comes up at the same time every year. The opposite sign this year. So whatever that sign is, you change it to the minus. Or if it's a minus, you change it to a plus. And then you just multiply these out. So 3 times minus 1 is minus 3. 3 here times minus 2I is minus 6I. Minus I times minus 1 is plus I. Minus I times minus 2I is plus 2I squared. And that's going to be all over. Minus 1 times minus 1 is 1. You're going to have minus 2I plus 2I, and then it's minus 4I squared. So that's equal to minus 6I. So minus 3, that's going to be plus 2I squared, so it's minus 2. Because 2 times minus 1, so that's minus 5. Minus 5I. That's going to be 1 plus 4, so it's 5, which can be written as minus 1 minus 3. And that's that one there. And the last part of this question was as follows. Now, if there's any bits you're not sure of, you can email me or you can just play the video back to see it. Right, so we have here. So 2z equal to minus 6 times 4 minus 6, or sorry, wrote that wrong. So 2z minus 6 times 4 minus 6i is equal to minus 1 plus I times 4 minus 2i. So we have 2z minus 24 plus 36i is equal to minus 4 plus 2i plus 4i minus 2i squared. And then what you do is you do 2z, so you leave the z and move everything else, or we bring everything to the other side. Sorry, we do 20 minus 24. This is just algebra. So what we're going to do here is minus 4, that's going to be plus 2, because it's minus 2i squared, so change it to plus 2. So that's minus 2, plus 2i plus 4i is 6i. And finish this off now. So we're going to bring the 24 and the 36i to the other side. Plus 6i minus 36i. So 2z is equal to 22 minus 30i. So divided by 2, 11 minus 15i. And that was that question there. Okay, and you have to remember, guys, these questions 12.5 minutes. So they're not overly difficult, but it's just to understand that because they can't be. So if it's taking you more than that, you're probably just kind of overcomplicating it. So for this one here, it says, so we'll start with question 2 here. So we just take a picture of these parts here. Okay. Again, just find this about here. Now, so z1 is equal to 1 plus 3i, and z2 is 2 minus i. So z3 is z1 plus 2z2. z1, 1 plus 3i, plus 2 times 2 minus I. So that's 1 plus 3i, plus 4 minus 2i. 1 plus 4 is 5. 3i minus 2i is I. 5 plus I. And then part 2 of this question, it says plot Z1, Z2 and Z3 on an arc diagram. Okay? I'm just going to move this over here. So Z1 is 1 plus 3i and minus I. Okay. Okay, so you have 1 plus 3i, 1 plus 3i, 2 minus I, so you've got 2 minus I, and 5 plus I. And then you label them, Z1, Z2, Z3. Now it's also very important you have your real and imaginary axis, and you do that. So that was the first part of that question, from part A and B. Now, just scroll down a bit, and we're going to bring in part C and D now. So again, look, it's the same type of questions you get asked each week, or each year. So look, investigate. So we've done these type of questions before. It's the same methodology, it's the same type of question that you get. So investigate if Z2 minus Z3, the modulus of that is equal to Z1 plus Z2. So if we get Z2 minus Z3, so you do what's inside the lines first, okay? So Z2 minus Z3, which is 2 minus I. Now, this is where you just be careful with your sign. So minus, and then it's 5 plus I. So that's equal to 2 minus I minus 5 minus I, which is minus 3 minus 2I. And then to get the modulus of that, it's going to be the square root of minus 3 squared plus minus 2 squared, and that is equal to 9 plus 4 square root of 13. Now we're going to do Z1 plus Z2. So we do Z1 plus Z2 first of all. And just to remind ourselves that Z1 is 1 plus 3I. So it's going to be equal to 1 plus 3I plus 2 minus I. So that's equal to 1 plus 2 is 3. 3I minus I is 2I. And then if you're going to get Z1 plus Z2, the modulus of that, square root of 3 squared plus 2 squared, and that's equal to square root of 13. Now, if you want to look just as follows, right? And just to show you how this works, okay? So Z1 plus Z1 and Z2 is basically, they're the same distance, or when you add them together, that they're the same distance from the modulus. Okay? So 3 plus 2I, which is here, to show you this, 3 plus 2I is there, and the other one we had was minus 3 minus 2I. So if I was minus 3 minus, it's going to be down there, so they're the same distance apart. Okay, and the last part of this question is find the complex number Z1 over Z2. So Z1 over Z2, so we'll just do that now. So the last part of this question was as follows. You were asked to get Z1 over Z2. So again, you get this every year. 1 plus 3I over 2 minus I. So you multiply it by 2 plus I. So that's going to be 2 plus I plus 6I plus 3I squared. And that's 4 minus 2I plus 2I minus I squared. So that's 2 minus 3, which is minus 1, plus 7I. Hold on now, did I just check that? 1 plus 3I times 2. Yeah, that's right. So 2, always check it, plus 6I plus I plus 3I squared. Yeah. And that's all over 5. So that could be written as minus 1 over 5 plus 7 over 5i. And that's how you do that in there. So that was that question. That was that assignment there, guys. If you have any questions on it, please email me. And or add to complex numbers at all. But that should be a question that you should be confident of doing and that you have to do for the exam. It should be a guaranteed 30 marks. Okay. Thanks, guys.